Now, by the end of this year, that Orion crew capsule will be uncrewed when it goes around the moon. But by 2023, we're going to send American astronauts around the moon, and by 2024, we're going to be landing on the moon.
Well, thank you so much, Administrator Bridenstine. I'm sure you want to get somewhere a little warmer where you'll be able to watch the test.
Great to be with you.
It's great to be with you, too. Thank you so much. It was just a few weeks ago that we announced the astronauts for the Artemis program. Let's take a look and meet those astronauts right now.
Okay guys, welcome back to Rocket Gyan. Here there's a bit of, you can say, mess here, because NASA initially planned to conduct this live stream a bit ahead, but now they suddenly just went live, and I have to, whatever I had plans, I had to just skip all those things and present it to you, these things. So just listen up. And I also don't know the T-0 when the rocket will actually fire up, so I'm trying to figure out everything just messed up because the NASA just suddenly started the stream. So please listen to them, and yes, you can surely drop your questions here and I'll try to answer them, but till then I'll try to figure out what's the T-0 and update you to this as soon as possible. Okay.
Hi, I'm Chell Lindgren. My name is Raja Chari.
Kayla Barron.
Kate Rubens.
Hi, I'm Christina Cook.
NASA astronaut Joe Acaba.
Jessica Amir.
Woody Hoberg.
Anne McClain.
Stephanie Wilson.
My name is Johnny Kim.
Nicole Mann.
Victor Glover.
Jessica Watkins.
Hi, I'm Matthew Dominic.
Jasmine Mogbelli.
Frank Rubio. Scott Tingle.
This is what we do. This is what we will do.
Let's go.
We go to the moon to learn how to live on other planets.
For the benefit of all.
If you are just joining us, welcome. The engines on the SLS core stage are expected to fire up at 4 o'clock Eastern, 3 o'clock local here at Stennis Space Center. Before that happens, let's get a closer look at the Space Launch System. NASA's Space Launch System is Artemis's super heavy lift rocket and provides the foundation for human exploration and scientific missions to the Moon, Mars, and beyond. Powered by 2 solid rocket boosters and 4 RS-25 engines, this rocket provides unprecedented power and capability. Designed to reach 23 times the speed of sound and an altitude of more than 100 miles in just over 8 minutes, offering more energy, volume capacity, and payload mass than any rocket built today. Under the launch abort system, Orion and the upper stage, and between 2 solid rocket boosters is the heart of every SLS configuration, the core stage, towering 212 feet with a diameter of 27.6 feet, and storing 537,000 gallons of liquid hydrogen and 196,000 gallons of liquid oxygen. This is the world's largest core stage ever built. The core stage for Artemis 1 fires up for the first time at NASA's historic B-2 test stand.
And this test stand is very historic because here only the shuttle engines fired up, the Apollo engines fired up, and most of the major rocket engines which were developed and which had a remark in our history, they fired up. So that's why it is very historical.
Long ago. Let's just go back one step and talk to me about how this was built and assembled at Michoud Assembly Facility.
Absolutely. So originally the core stage was designed up in Huntsville by our SLS program team and also our Boeing team. And then, manufacturing began at Michoud Assembly Facility in New Orleans. It's our state-of-the-art manufacturing rocket facility. It's more than 44 acres under a single roof. And obviously through the production of that rocket, we eventually moved the core stage from Michoud Assembly Facility here. That process is no easy feat, a lot of coordination at Michoud to be able to ship that thing and get it here in the proper amount of time. And so
You're talking about moving a rocket on the Mississippi River.
right, yeah. So we have a barge called the Pegasus barge, and this barge is it's kind of our carrier for the core stage. It's a fully covered barge, and it carries our core stage all across the Mississippi and eventually to Kennedy Space Center.
And then when it lands here, how do you get it into the test stand?
So whenever the core stage does arrive to Stennis, we have a very talented and very experienced lift team, and they bring the core stage to the sand. They lift the core stage in a very slow process and lower it into the B2 test stand, secure it, and then we begin our rounds of testing.
Your rounds of testing, what does that look like?
Well, we actually have a series of green run testing. This is actually the 8th test in a full series of green run tests that we've been performing over this past year. We start with modal testing, which is kind of testing the vibrations and the structure of the rocket to see how it's going to react when we do the hot fire. And then we do things like powering on the avionics, all the electronics equipment, and then we move into activating safety systems, testing NPS components, and kind of piece by piece building on what we previously did to finally get to the point where we are today.
And today we call it the Green Run Hot Fire Test. Why is it called the Green Run?
Well, the green run really refers to the parts in the rocket never being flown before. So, obviously all these parts have been tested by themselves, but they've never really been tested as one giant unit. So today we're really looking to get all that data and fire for the first time. And then obviously the run refers to all the series of tests we've done to get to this point.
Well, Alex, thank you so much. Again, we're going to be coming back to you. We're also later on in the show going to start hearing some audio from the control room, so I'm going to be relying on you, Alex, to let us know what they are talking about. And the hottest part of the show today will be those 4 RS-25 engines at the bottom of the core stage. An interesting fact, these RS-25s we're testing today are repurposed from the shuttle program. These 4 engines flew on some pretty iconic shuttle missions, including one of the Hubble Space Telescope servicing missions, the historic return to space of Mercury astronaut Senator John Glenn, 6 flights to the space station, and the final space shuttle mission in 2011. So you can trace a direct line from that final shuttle flight to the first flight of SLS. We've worked with our partners at Aerojet Rocketdyne to upgrade the 16 shuttle main engines, which will power the first 4 Artemis flights. And now we're building 24 new engines using 3D printing and other manufacturing innovations to reduce cost, complexity, and manufacturing time. And a reminder, the test teams here are looking at 3 o'clock Central, 4 o'clock Eastern for today's hot fire test. Of course, many of the teams who worked so hard for this day can't be here in person because of social distancing, but they are still cheering us on virtually.
Human Resource Business Party at
Okay,
Stennis Space
so
Center, America's largest rocket industry.
yes, as Louis Smith mentioned, if you have any questions you can ask me. Actually, I had so much things planned for this mission and this hot fire test. Actually, I need to talk about so much, but this happened that NASA rescheduled the stream and I don't know, everything just messed up. So now we can't do much about it, but just listen into them, and then after the fire test is commenced, then we can have a chat about everything. Okay, so yeah, listen to them now.
We are Boeing, and we are so proud to be part of Team Artemis. All right, guys, let's light it up.
It's so great to see the team cheering us on for this historic event. And you guys have been cheering us on online also. And in celebration of being one step closer to landing astronauts on the moon, we've been asking you, what would you take on a trip to the moon? Let's take a look at some of the entries that we've received. We have an entry from the New Orleans Saints. And Marcus Davenport from the New Orleans Saints, he would pack his helmet and a football. What is a trip to the moon without a helmet and a football? Who dat? We also have an entry here, Moon Kit from Storm Lake Elementary STEM. It's great to see the little ones packing their moon kits. Storm Lake says that our moon mission is back on track. Students K through 1 are preparing to blast off next week by packing their moon kits. And in their moon kits, they have a soccer ball, an astronaut suit, shades, and a camera. You never know if it's going to get bright out there. Good job. We love your moon kits. And how exciting is this? We have an entry from the one and only Marie Kondo. Let's take a look at Marine's moon kit. She is packing a blanket because she gets cold. I could use that right now. She has boxes to keep things tidy. She knows how to pack. And she also has a picture of her family because they spark her the most joy. Awesome. And in responses to what would you take to the moon, we've received some really creative entries. Let's take a look at some more of those entries that we've received. I'm really excited to see some more of these.
Like I can play this music, but yes, you can just have a look at the visuals right now. But yes, okay, so I can talk about some of the things for this rocket. So today you will be witnessing a hot fire test, which is nothing but a static fire test for the SLS core stage, which basically has RS-25 engines, 4 RS-25 engines, and those engines were used in the space shuttle. So those engines are basically flight proven engines, and these engines had some changes in the software, some adaptation, and some other other adaptations and other improvements to match the performance which is required for SLS moon rocket. So yes, that's what it is, and today they will be firing it, and it will be mostly used to test the whole rocket and not the engine only, because the engine is flight worthy and they know that they will work. They have been using these engines for the shuttle for so much long, so yeah, they know that engines are working and they will be usable. Only thing which they will be testing today will be the whole rocket, how these engines will behave with the whole rocket, how the fueling will happen, how the gimbling will happen, and all those things. So yes, that's what you will be looking at, and this will be the first time that the 4 RS-25 engines will fire simultaneously, producing 1.6 million newtons of thrust, and this will be a full duration test of around 8 minutes. That means that is the flight duration of the main core stage. So yes, they will try to simulate as how the the actual flight will look like, and how the gimbling will happen, pitching and everything. So yeah, that's what they will be looking at now. Okay, so yes, now you can I have actually given some brief intro about what you will be seeing. So yes, now you can see it properly.
Complex, and what we do here is we run a lot of simulations to ensure that we have validated the systems and integrated them together. So we actually have special software that's a version of the flight software, but it's really specific for our green run test. And so that testing has also been integrated into this laboratory and with all these avionics boxes to ensure we have a successful hot fire. Best part of the job is working with all the people and the teamwork. It's been extremely fun to watch how everybody has pulled together with the same goal in mind. We have more than 1,000 companies across the United States that support us. Some of them are small mom and pop shops all the way up to the big contractors. And each one of the individuals that have been working with us have a significant contribution, and they should be extremely proud, not only when we do our Green Run Hot Fire, but when we have our first Artemis mission launch.
If you're just joining us today, we are live at NASA's Stennis Space Center in Mississippi for the Green Run Hot Fire test of the core stage of our Space Launch System rocket. At about 4 o'clock Eastern, over there at our historic B-2 test stand, we are going to fire 4 RS-25 engines for up to 8 minutes to prove this rocket is ready to launch later this year on the first Artemis mission to the moon. Again, so many people have worked to get us to this day, and even if they're not here in person, they are ready for this big milestone.
On behalf of all of NASA employees and NASA contractors at the Michoud Assembly Facility, home of America's rocket factory, we wanted to show our appreciation to everyone supporting the Green Run Hot Fire. We are with you, and together we are making history.
My name is Preston Jones from NASA's Marshall Space Flight Center. I'd like to say congratulations to the SLS team, to the core stage team for this great milestone achievement. As we go into Green Run, let's say go Green Run. Go Green Run!
From everyone here on Team SLS, we want to wish Spinner and everyone down there at the B2 test bed a happy and successful Green Run. Go Green Run and SLS.
We have an update for you. Again, this is a live show. We are hearing what you're hearing, and we are learning as we are moving through this day of test. Alex, do you have any update for us on why we might be possibly going faster or slower, or what this is like right now?
Yeah, so our test conductor just alerted us that they're working through a few issues on the stand. You know, like we said, this is a test, so we will see some delays or some possibly, you know, some issues that we'll have to work through. It's all part of testing. So as we get more information in, we'll tell everyone and we'll work through it.
And we did talk about this. This is a test. This is not a demonstration. Why is it so important to test today?
Right. I mean, the whole point, right, is it's not a demonstration flight. You know, we're out here to test a rocket, learn as much as we can, and that'll really not only help us for the first Artemis mission, but for all of our future Artemis missions as well.
And so what are we actually learning? We've got a lot of different components, a lot of different pieces of the rocket that we're looking at. What do these tests really look like?
Well, we're really here to simulate almost what a launch would be like, right? The whole core stage with the computers and everything, it thinks that it's going to be launched. Even though we're holding it in place and testing it, we're basically going to put it through a round of testing that's going to simulate the launch. So the whole point is to make sure, one, to verify that the core stage can perform that way, and two, get the data that we will need for launch today.
You've touched on this, but how much do the NASA engineers really not know about this rocket? What are you really learning, and what are you just guessing or finding between the data points you're already guessing?
Well, obviously our team, you know, knows a lot about the rocket. You know, they've been part of this project for a long time, everywhere from, you know, the beginning of the production to designing the rocket to testing the rocket. You know, they've been part of every step along the way. But even then, you know, you're constantly still learning, and that's part of the whole process.
Guys,
that's part of the process with any
cost per launch for this rocket actually will be around $2 billion. Yes, and that is pretty large and pretty huge. $2 billion per launch, and the development launch for this rocket is different. This is just the cost per launch. Whenever this will be launched, that $2 billion every time whenever it will be launched. So it is a pretty expensive rocket. Yeah, that's what. And now they will be actually firing it and simulating the launch condition, and let's see what happens. These are the 4 engines you can see right now, and I am really very excited. The 2 million pounds of thrust and hold down clamps will be actually keeping that into place, and I'm really very excited to see everything. So let's see how it goes.
You turn on individual avionics boxes, and then you have to charge the batteries, right? And so you're slowly turning it on one by one and doing verifications of each system as you do turn it on, finally to the point where you have one large core stage working all together simultaneously.
And you talked about temperature changes. Can you describe the changes that the engines will go through today?
Right, absolutely. So the fuel that we're adding to the core stage, right, that's our liquid oxygen and liquid hydrogen. Both fuels are very, very cold. You know, they have to be very cold to be in liquid form and not in their natural gas state. So, you know, we're looking at temperatures -400 degrees, you know, a little bit more than -300 degrees. for those two propellants. And then when it comes time for ignition, in less than a second, we're getting up to a few thousand degrees temperature.
That's a big difference really quickly.
Yeah, it's very fast, and that's part of the thing which propels the core stage and the rest of the SLS off of the Earth's surface.
I gotta say, you're keeping calm. You've got a cool level head right now, but I have to imagine you're excited about this. You've been working on this for years.
Yeah, it's an absolute surreal experience, for everyone who's been working on this, for the last few years and even longer than that. I think everyone's really excited about the core stage test. Everyone's excited to see it be launched for Artemis 1 and for the future Artemis mission. So I know the whole team's working hard. The team in our test control center is working very hard. So, I think everyone's just looking forward to it.
I do want to talk a little bit more about the team because we see some people here, but it's actually people across the country. Can you talk to us a little bit about the different companies that have gone into integrating with NASA here and how all that comes together?
Yeah, absolutely. We have thousands of parts on the rocket, and there's tons of companies and subcontractors, small companies, big companies. And so, we've had parts from more than 44 states across the nation. And then obviously, our Boeing contractor, our lead contractor for the project, they've been working hand in hand with NASA the whole time. Those teams have really been performing really, really well thus far.
And the white smoke which you were seeing coming out of the nozzle of that engine is actually the fuel which is actually running through the engines and making it ready for the ignition. That's what you are seeing right now.
Take some water and listen in. We actually would love for you to listen in to the control room so we can come back and ask you exactly what they're talking about. Give us a breakdown. I'm excited now to be talking to an astronaut who is here with us, Tracy Caldwell Dyson. Tracy, it's so great to meet you. Thank you so much for being here.
My pleasure. It's a real honor and a privilege to be here, so it's going to be exciting.
Well, first I want to talk to you about the act of launching off this planet. You have flown on the shuttle, STS-118 specifically, and one of those engines that flew you to space is powering this very core stage. That's pretty cool.
That is really cool.
All right, I have to ask you first basic question. What does it feel like to launch?
Oh gosh, there's so many feelings. Even before you even get inside the vehicle, as you're walking up to the launch pad, and you see this mammoth rocket standing before you, and from the sensations to the things that you see to the things that you realize, you've got a job to do, but yet you're doing this incredible. You're having this incredible experience. From the light off of the engines to the lift off, the swaying of the rocket, the rumble, all of the vibrations, the controlled explosion happening underneath you, to the constant acceleration that you're feeling as you're propelled into orbit, to the engines are throttling. All you know is that you're just going fast, and then you're in there with your buddies. You've been training all this time. You get to the solid rocket boosters. As soon as they expend their energy and they separate from the vehicle, and you're just riding on those main engines, the RS-25s. I remember being so impressed with how smooth and powerful that ride was. It was like riding on rails. And then, of course, the moment you get into orbit, it's some of the most strange tranquility that you've ever experienced in your life.
I want to ask you to do something here. If you'll indulge me for a second, let's just take a look back because we are about a mile away from SLS.
Well,
as you take a look at that, what's going through your mind?
I have to give it up for the folks that are in the control room right now, because I can remember how I felt standing at the foot of the rocket before I launched on it. But all of those folks, like Alex was mentioning, that have played a role in this, plus the ones that are around the test stand, that is their baby. And when those engines light, there's a lot of hands and eyes and hearts and soul that are in every ounce of thrust that are coming out of those engines. And so I think when I look at that, I just think about all of the people who make up the body of that rocket and the thrust that's coming out of it. And I'm really excited for them.
Excited for all of us.
Yeah.
And it's exciting for all of us here. And what's the difference with the excitement in the astronaut community?
Oh, goodness. Well, I tell you what, there's a whole lot of other blue flight suit folks that wish that they were here today. We are just genuinely excited about this opportunity to go further than low Earth orbit and explore again our moon, and to set a foundation along with those footprints, and to go beyond that, and to just be here at this time with all this excitement is a real privilege for all of us. But as a Corps of astronauts, we're just really excited about where we're headed. So.
All right, you said moon. So as we progress towards the moon, talk to us about the significance of the human element in space. Why is it so important to put humans back on the moon?
Oh, goodness. I think there's so many ways to answer this, but I think, you know, we have it inside each one of us to discover, to explore, to let out our creativity. And I think the reason it's important for humans, I mean, technically it's important because we know how to make decisions right then and there, especially with time delays and not having a camera view every single place you need to look. It's, I think, vital to have humans involved. But the spirit of exploration is within our hearts, and there's no other way to live it out but to send our humans to these destinations.
And there's a lot of people watching today, and a lot of kids watching today, young girls watching today. Do you have anything you want to say to them specifically?
Oh, goodness. Well, with what time we have left, I would say that the most important thing to do is to know what you enjoy doing, and start now taking note of those things, because what we really want is the best in you, and what brings the best in you out for everyone to see is doing the things that you enjoy. And so I would encourage everyone to go and explore all the things that you are doing right now, and ask yourself if you didn't have to get a grade in this, would you still be doing it? And so I just think that it's within their reach to fulfill their dreams, as long as what they're doing is what they enjoy.
Stay curious.
Stay curious, absolutely.
Well, Tracy, I'm lucky to be with you. We're both lucky to be here right now, but there are a lot of people at home who've got questions for you, too. Would you mind if I asked you some questions off of Twitter?
Please do.
All right. We're going to jump to a few questions we've gotten in. The first one is from Amber. Amber on Twitter asks, what is the main mission, or what do you hope to learn with these next series of landings?
On the moon, I think what we are trying to learn is just make sure we know how to get back there, and then to set up our mission so that we can come back. And our whole goal is to lay a foundation on the moon and make it sustainable so that we can continue to come back. And so I think the most important thing is to test our systems and to make sure that we can duplicate it.
So make sure we don't get lost, and that we know what we're doing when we get there. Okay.
That is highly important.
That's a great answer. All right, another user on Twitter asks, what would be your final meal before leaving for the moon?
Oh, goodness. What would be my final meal? You know what? I would, this is going to be boring, but I would want a salad.
What?
Why? Because I want fresh food before I go, because the rest of it's going to be all dehydrated, I'm pretty sure.
Do you get queasy on the launch, too?
No, I didn't, and I think part of that's because you are so highly trained, and you've got a job to do, and you're highly focused. And with all the G's pressing against you, it kind of keeps your stomach still.
It's keeping it down.
Keep it all in there.
One last question for you. What is the coolest thing you've experienced being an astronaut?
Oh, I got to say that it is being in shorts and a T-shirt, living on board the space station, looking out the window and gazing at this beautiful planet. That probably is the most exciting, coolest thing I've ever done as an astronaut.
Well, Tracy, thank you so much for being here. I hope you get to enjoy the show. And thank you to everyone watching and submitting questions online. What we're going to do right now is we are just going to watch with you. We're going to take a step back. We are going to watch the test stand, and we're going to listen in. And we are going to ask Alex to please pay extra special attention, because we're going to come back and ask you what's going on in the control room. So again, we are going to take a step back and all just watch the test stand for just a few minutes.
Okay, so looking like it is happening now, although there could be some delay with the timer, that the timer which we have right now is approximate. So let's hope I don't think so it will fire at that time. Maybe it will take some around a few minutes from now, but let's see what happens. Looking like it is happening, but that is really great. Does not feel like. Okay, let's see what happens. So this is the view of the underneath of this engine, and you can see it is being pumped with the fuel so as to make it chill, and yes, make it ready for the ignition. As we know, we missed the timeline here, but let's see. They haven't released anything. The problem is that if they had something, then we could have known. So although the window, we just know that the window is around 3 yard long window which they have for this test, and it starts at this window and they have crossed that. So let's see what do we have in store for us. Till then, if you have any questions, you can ask me, but I think it would be better to listen in the engines of this mighty rocket breathe. So yeah, I should stop talking and you just watch it.
And a reminder, we are in a dynamic situation. The teams are in a hold right now. We are still well within our window for today's test. The teams are working towards getting an updated test time for today. So we have Alex with us, and Alex, we were listening into a little bit of the control room audio. What does it mean that we're in a hold, and what were you hearing from the control room?
Right, so right now we're still in a stable replenish, and basically what that means is we're still getting fuel into the tanks from the facility, and the replenish cycle is kind of meant to maintain topping off the tanks to their full capacity as some of that liquid does turn back to gas, and we've been off that gas. So we are in a stable replenish phase. Obviously, some of our engineers in the test control center are seeing some data that they don't like or might be not exactly normal from what they usually see. So those teams are off now, kind of having sidebar conversations with each other to kind of determine what we need to do to go forward.
So I want to go back, because all this might be obvious to you, but we're trying to figure out where we are in this whole process. We thought, we might just come here and see the engines light up, but that's not what happens. So what happened up until this point, and what are we waiting on now?
Right, so like we said, we powered on the vehicle, right, over the last few days. We've repaired all the systems, we've tested all the systems, and then this morning we started tanking, by filling both our liquid hydrogen and our liquid oxygen tanks with propellant. And so that's really been the long process today. I mean, obviously we have to chill down our main propulsion system, so all of our mechanical parts have to be chilled down to a certain temperature before we do hot fire as well. So, right now they're obviously working through some issues in that process, and as we learn more, as they learn more, we'll learn more. And so whenever we do hear audio, we'll be able to give a better update.
So why don't you tell us a little bit about that process? We're talking about chilling down the engines themselves.
Right, yeah, all the engines and all the components inside the engine section, which holds the engines, have to be chilled down to a certain temperature before you start the actual hot fire, the ignition of the engines. And that's just because they're meant to operate under those cold cryogenic temperatures. And then obviously when you're hot firing the engines, you start to heat up those parts, right? So you want to cool them down to a certain point, and then obviously you'll heat them back up whenever you're firing the engines.
So say this hold is lifted, what will happen next?
So when we do, or when they talk about the hold and they lift it to continue operations, from that point, we're at the point where we'll start to move into our T-minus 10-minute countdown. And that countdown kind of moves into our final sequence of activities to finalize right before we get to the actual hot fire. So there's a whole set of activities we get every few minutes, and that'll kind of determine what time we will fire, and then that we are actually going to fire.
Will we be able to see anything during that T-minus 10 countdown, or really not see anything until the last second?
Yeah, you'll probably see a few things, and a few of those things you might be able to see right now. The water suppression system is operating. It's not operating at 100% right now because we're obviously not hot firing the engines. But when we do, you'll be pumping 100,000 gallons of water every 20 seconds. You'll be able to see, obviously, some of the engines gimbal, which are moving in a few degrees in different directions. And that'll be part of the run-up until we actually do activate each engine.
And you've told me this before off stage, but I thought this was fascinating. So we haven't had a test like this since the Apollo era. And there was something that happened then with a giant plume that actually made it start raining on everyone out here. Can you tell us that story?
Yeah, absolutely. A lot of people don't realize is, we have our two propellants, our liquid hydrogen and our liquid oxygen. And when you react with those two chemicals, you're really just creating H2O. So when you see the big plume coming out, it's just water vapor, right? And, since when we tested Apollo, back during the Saturn V program, the amount of water vapor coming out during that test is quite breathtaking, and also it's so much that it can create clouds and sometimes rain clouds, so sometimes you can get rained on from that.
All right, so we can expect possible rain, even though it's a beautiful, cold but sunny day today. What else can we expect to see?
Right, so you'll hear the test conductor audio when we get into our T-minus 10-minute countdown. So after that, you'll hear, every few minutes him come on the phone and say, hey, we're getting to this step. And then you'll hear the engines rev up for the hot fire.
Well, Alex, thank you so much. We are going to remain live. I might be coming back to you in a minute, in 10 minutes, but we are really excited to have you here explaining everything to us. And a reminder to everyone at home, this is a live test. We are still listening in for the control room teams as they review the data of the test up to this point. They are having a conversation right now about the appropriate steps to move forward. So, Alex, we've had a little bit of a talk about those discussions. Again, we're going to be coming back and forth to you. And again, a note to our viewers, we're going to be hearing calls from the test conductor at regular intervals over the next 10 minutes or possibly more. When we hear those call outs, what we're going to do is we're going to pause and listen in. I might turn to Alex and have you explain them to us again. For right now, what we're going to do is pause and listen for some of those so we can try to catch up with the rest of you and everyone in the control room, find out what's going on, and just take a step back and look at the beautiful SLS on the test stand now.
So it seems like we will be having some time here. Hopefully we are like a T-minus 10 minutes short, so whenever you will hear the mission control room, then yes, you will get to know what they are going in through. But yeah, so we do have some time now, and we can talk about this rocket. So this rocket is first of all, if you don't know, this rocket is powered by 4 shuttle derived engines. So the engines which are right now you can see are the RS-25 engines which actually powered the space shuttle. Okay, and this engines are not exactly same. Obviously they have made some modifications in it, updated the flight computers and made optimized it with the with this era of technology. So yes, that's what it is. And other thing which is shuttle derived are the boosters. So it will be having a two solid rocket boosters attached with the core stage. The thing which you are right now seeing is the core stage with the 4 space shuttle engines, and there will be 2 boosters which are also shuttle derived. Okay, so yeah, which are also shuttle derived, and yes, that's what we have. So other than that, it will have an upper stage known as ICPS Block 1, which is nothing but the interim cryogenic propulsion stage, which is planned to fly on Artemis 1 mission. So it is a stretched and human rated Delta 4 5 meters Delta cryogenic second stage. So Delta 4 cryogenic second stage, but stretched and human rated. So yeah, so if you know that, if you have seen that launch or not, I don't know, but there was one launch on the Delta 4 Heavy, and on that Delta 4 Heavy they had the Orion capsule, which will be launched on this rocket. So yes, that rocket, actually they initially planned to launch on Delta 4 Heavy also, but then they skipped it because it was proving to be too expensive, and they had some problem with the human rating also, human rating the boosters and the engines. So yes, they switched over to the SLS. Hi Nivat, hi Octagrabber, hi Louis Smith, hi Cesare Kolak, if I'm not wrong, and hi Sanjay Agarwal. So yes, that is the thing. Then and then we have then exploration upper stage also, which is planned for Artemis 4 mission. So that is what the rocket configuration looks like. But what will be the payload capacities? Well, we know that this is a super heavy launch vehicle and is the most powerful rocket till date. So the payload capacity to the low Earth orbit is around 95 tons, and payload capacity with the TLI, which is the translunar injection, is 26 tons, which means
kind of keep it down in the control room, please. We are coming up on another event here in the terminal countdown timeline, coming up on about T-minus 40 minutes or in about 2 minutes.
I didn't get it, what he just said, but okay, you'll get the updates, no worries. So yes, I was talking about it has capacity of putting 26 tons into a translunar injection orbit, which is nothing but it will with the 26 tons mass, it can raise the orbit from the lower orbit to an orbit which intersects with the moon. So that is 26 tons. I mean, wow, literally wow. Countries does not even have a rocket which can have 26 tons payload capacity to even at a low Earth orbit, and this rocket can put 26 tons to a translunar injection. That is simply incredible. That is the configuration for the Block 1 variant. Then we have the Block 1B and Block 2 also planned, and for the Block 1B, the payload capacity to the low Earth orbit will be around 105 tons, and to the translunar injection it will be 40 tons. So this is an upgrade onto that. And then they have a Block 2, which is the most epic one of all of them. It has a payload capacity of 130 tons to low Earth orbit, 45 tons to the translunar injection orbit. So I can't even tell you how powerful this rocket is, and that's the reason why this rocket cost around $2 billion to make. But yes, the Starship is always here. The only the thing with the Starship is capable of what this is doing, and it can very well do that. But the only problem with the Starship is that it is in the development phase. Okay, and they need to reach by 2024, although that timeline would not be met, but the Starship is still in the development phase. And with the SLS, they already have all the flight hardware. They are just now testing it, and the testing only is taking so much of time for them. So yes, obviously the Starship will be much
personnel. We're going to be picking up on page 3.27. We're at the T-minus 40 minute time mark event. Step 4.61, SCE. Let's go ahead and initiate the terminal count sequencer IOC for substep alpha. go ahead and enable TCC user underscore hold. Let me know when that's enabled.
Copy. User hold enabled in green.
Copy, and then please enable STCTR48, please, the stage controller terminal countdown engine anomaly, if not already enabled.
STCTR48 enabled in green.
Copy that. Takes us to step 4.62 sequencer. Let's go ahead and perform the stage controller terminal count sequencer setup as follows. Please ensure the countdown timer is open.
CDT window is open.
And ensure your display test commit criteria is also open.
TCC display is also open.
Copy. And we're going to go to sub-step Charlie. If you would, verifies on the terminal count sequencer that the ISC has been initiated.
Verified initialization was successful.
Copy. And verify engine configuration is hot fire.
Engine configuration is hot fire.
And verify display configuration is hot fire.
Display configuration is also hot fire.
For sub-step 4, please record the version of the GLS events table being used for today.
Okay, version hot fire, version R98 Rev 8.
Did you copy that, BQA1?
No, sir.
Engine configuration being used today is hot fire, version R98 Rev 8.
Version hot fire R98 Rev 8.
Correct, Red Alpha.
Copy, it takes the top of...
A is that Alpha, right?
Hot fire R98 Rev 8, copy.
Okay, that takes us to the top of page 328 for sub-step 5. Verify that the engine configuration is the desired version of the GLS events table that you just mentioned.
Confirmed.
And verify the display configuration is also the desired version of the GLS events table.
Also confirmed.
Okay, under your TCS engine status, verify activate sequencer is selected and displayed.
TCS engine status activated.
Copy that. Okay, per the note there, TCS will automatically stop at the T-minus 10-minute hold point. HEA, if you're on 16, step 4.63 is yours.
Copy that. NTCs is HEA in 16.
Give me a second. Here's coming to 16.
Go for NTC. NTC, can you please verify and or perform a helium spin start panel activation per DOP 11 to provide 1,000 to 1,300 PSIG to the CAPUs?
Roger that. It is set up.
Copy that.
It is complete.
Record a UTC on that of 016 21 17 07.
Copy 016 21 17 07.
Copy that, and the NTC, the next step is yours per step 4.64, please.
Roger that. And in BTC, let's go ahead and prepare the deflector for test configuration. And he's on the phone, but he's been coordinating with the water plant, and he'll get the bypasses open in just a moment.
Copy that. And then NTC, per our discussion, we will we will maintain the current timeline and the current countdown time per our discussion.
Roger that. Sounds good.
So it seems like I didn't get them properly. Were they saying that put the countdown to T-minus 14 minutes or 40 minutes? I didn't get that, but well, that was a pretty long discussion with the mission control there, and yeah, those are just the steps they were repeating. They were basically telling everyone and verifying everything is going perfectly, and that's the standard procedure which they were following. So yeah, so yes, I was talking about the Starship with the this SLS rocket. I was telling the problem, the only problem which I actually see with the Starship is that it is still in the development, and this rocket flight hardware is already flight proven. The boosters are flight proven, the engines are flight proven. So yes, they just need to assemble each and everything, make sure that tanks does not explode or implode, and are able to withstand the launch environment and everything. So yeah, they just need to test this thing. That's what they are doing, and that's why SLS is in existence, because Starship will definitely take time. And yes, well, see that right now Starship is now right now in development, and the second stage is developing, and then the third for the Super Heavy will be in come in development. And if everything goes all right, we can like expect something like, as in till the end of this year, I can expect that fully established and developed kinda the second stage of the Starship is actually developed. So yeah, till the end of this year we can expect that, and then the Super Heavy will also develop in the subsequent year. After that everything is developed, then also the problem is that they need to human rate it if they have to actually have the humans on board. So that will also take some time.
Stennis Space Center. The teams are in a hold, but we are still well within our window for today's test still, and I am lucky to have Alex here with me. We've heard a lot of conversations from the control room over the past few minutes. I heard hot fire a lot. I heard water a few times. You're the expert. What were you hearing?
So the test conductor instructed everyone to go back into our terminal countdown sequence. And so at this point, we are about 30 minutes away from the hot fire according to the terminal countdown sequence. Some of the other things they're kind of talking about, they're turning on the water deflectors, right, for the engine test. So there's certain configurations that we need to put each thing on the stand or thing on the ground in a certain configuration for that hot fire. So they're supplying certain amount of pressure to different components inside the engine section, and like we said, turning on those water deflectors, retracting some of the stands around those engines, really to prepare the stand and the core stage for hot fire.
We heard at least two people talking, is that right? What were those people, what are those positions back there?
Right, so the test conductor is basically relaying information to individuals working a console, and each of those console workers are either going through test criteria, right? So we have test commit criteria for each part of the test. They're looking at different things that are happening with the stand. They may be controlling the water going onto the stand. So he is in direct communication with each person that is working each individual component on the stand. So you'll hear him giving out a lot of commands of things that need to go according to our countdown sequence.
And where are they? They're even closer than we are, right? And they're in a safe place, I hope.
Right, absolutely. They're in a test control center closer to the stand. And that stand is wired, has wires running all the way to the test control center. And in the test control center, they can see everything going on. They can see all the cameras, and they're each sitting at console, be able to make decisions real time. So, they're sitting in a building. It's fully blast proof, right? It has giant blast doors closed in there. So, the team's working really hard. There's a lot of people in there looking at a lot of stuff. So, they're obviously working through it and working towards hot fire.
And those two people we heard, are they sitting close to each other? Are they hearing each other kind of like we're hearing them now?
So the test conductor audio, he's in one part inside the test control room. So, he's talking in a regular voice, kind of like we are. And then he could be communicating with someone on a far end of the room, or he could be communicating with someone sitting right next to him, but that's all over the audio, kind of like we're hearing.
So is this considered normal when you think about testing a rocket?
Yeah, absolutely. That there's a ton of people who play a part in the actual test of a rocket or in the launch of a rocket, right? So you have to have a proper way of communicating, proper one-way or two-way channels, so that the correct people can be heard at the correct time. So everything that's happening is obviously planned as far as, communication and working through issues. And then now that we're in our close to 30-minute terminal countdown, we'll be hearing a lot more things over the radio.
And we heard about this window. So there's a certain amount of time that they have to be able to light these engines. It's not like a launch window where we're trying to reach the moon, so we have to pay attention to that. But what does this window mean?
So, you know, there's certain operating guidelines that we have for certain things in the engine. You know, there's certain times that we can have avionics boxes powered on, and there's certain times that we're allowed to have the batteries running on internal power, things like that. Obviously, while the core stage is integrated to the stand, we have a little more leeway because the stand is supplying a lot of that power, supplying a lot of, you know, the materials we need to continue testing. You know, it's going to be more of a process for them to determine what the next step forward is for testing. And I'm sure it's something we'll hear over the test conductor audio.
Okay, I'm going to be coming back to you a lot more. Again, we're going to keep you in the hot seat here, even though it's cold outside. We're all excited for the big hot blast coming in. I think you said about 30 minutes is what we're expecting. So again, what we're going to do, a reminder, this is a live test. We're still listening in for the control room teams as they're reviewing this data, as we're leading up to the test point. They're still having a conversation right now about the appropriate steps to move forward. So again, we're going to join you. We're going to take a step back and just watch. We're going to look at the test stand and listen in for the control center. We're going to let Alex digest it all for us, and we'll come back to you in just a few minutes.
Okay, so thanks Raymond, and thanks Kenal for subscribing, if I'm not wrong. So yeah, Minio Park R&D says lol, Starship is in dev, but this machine is a single use throwaway water waste. Okay, so let me just try to comment on that. Yes, I do agree that this will be in a one-time usage only, like they will launch this and then they won't be able to use it again. Agreed to that, and believe me, whosoever has designed this rocket, right, rocket scientists, engineers, and whatever staff is actually working with this rocket, does not want this rocket to go in waste whenever like it launches and just one launch and go in waste. They don't want that. They have literally had so many years of hard work and everything put into this rocket, and hence they don't want that to happen, but they don't have any other option also, right? They have to launch this thing, and it is like that they can't recover it. They don't have any plans for that. So yes, they will be like splashing down into the oceans, but the thing is, we know that this thing will be a one time, will be used for just one time, but just see the science which we can get from this mission. The moon, we are actually getting back towards the moon again. People used to say Apollo landing was fake, and Apollo landing is fake and everything is fake. Americans didn't go to the moon and whatnot, but as Neil deGrasse says that if you have to fake Apollo landing, you need to be like doing so much of stuff that it is easier actually putting some humans there and getting them back rather than just faking it. So yeah, they have all the documents, documentary data and everything. With that, they have the moon rocks, everything. So yeah, those whosoever, I can say that whosoever used to think that Apollo landing was fake, with the Artemis mission, they can get some sort of truthfulness on them. So yeah, that's what it is. So rather than pushing in for the recovery of this rocket, they are pushing in for the science. That's what NASA does. They are getting the funds and everything, so they want the science, maximum science output, and that's the reason why, since they have this hardware already lined up and already planned and already made, tested and whatnot, so they are using it. They are right now not thinking about recovering, they are thinking about the science and accelerating the presence of humans on moon. So yeah, that's the reason. Yes, yes, it is real. Obviously, it is real. The Apollo landing was real, and I already really believe in that. Everything is real. But I was just saying that again, after just 50 years or so, we will again be going back towards the moon. And wow, boy, I'm so excited for this. Whenever I think of this thing, now we are going back to the moon again. My mind just simply goes like just blows away. I can't even think of like we are literally we going back to the moon with the high-tech cameras. I'm really very excited about the cameras and the photos and the videos which we will get from the surface of the moon. I mean, in the 1950s era, we got such a high quality at that time compared to that time. That was that image which we got, the videos which we got was such a high quality. And now if when we will go to the moon, the cameras and videos which we will get from the surface will be mind blowing, I'm telling you. And that's what I'm really very excited for. The craters, the moon rocks, also they are going in for the south pole, so they will can actually be seeing the demarcation of the sun and the moon, the sunny side and the shady side. Maybe they could if they have landed in the certain area. So yeah, that thing will be pretty epic. I'm so excited for that. Hi Marcus Carter, how are you? And yes, I'm really very excited for that. Going in, people standing on the moon and talking with the whole world, that will be like another era to the space exploration. The Apollo accelerated that a bit and then it all went stagnant, and NASA also didn't actually want it to go because there was no reason to go back to the moon, right? But now we do have a reason. We have water, we need to investigate it further, we need to become interplanetary species, and the moon will be like used as a pit stop for the rockets to refuel and launch from them to the Mars and beyond. So it does make sense. Also, there are so many resources on the moon which we can harness for the benefit of humanity on the earth, such as one of them is helium-3, which is in abundance in moon, and it can power the, like, it is so you can say energy efficient. Like only some part of it can some like kgs of helium-3 can power whole US for around a month or so. So yeah, that's what the power of helium-3 is. Yes, Blues Traveler, they were not fake at all. They can't fake those things. They have all the documents and everything. They have the video footage. What else do you want? They have the technology to actually demonstrate and do what actually could work on the moon. Also, we have the Kerbal Space Program, right? The KSP. Whatever they did in the Apollo era can be done in the KSP, right? And in KSP, I know that it is not actually very real physics, but concept wise it is very much proven. So yeah. Hi Labrat, how are you? I'm very excited for this thing to fire up, and let's see how does this work. But I can see right now, like whenever the Starship will be fully developed with the human rating and everything, the SLS could actually go into hibernation for some time maybe, or could prove to be like a backup rocket for some cargo or something like that. The only problem with the Starship would be the the faith of NASA on Starship, whether they will believe in SpaceX technology or not, because they do take some time to believe in SpaceX technology, as they have now actually in what mission they did, I can't remember if it was an NROL 108 mission in which they used the reused booster. So after so much of reusability and everything, they proved that yeah, the reusable boosters are also flight worthy and they are also successful. Then after that, the NASA and NRO were able to grant the access to, yes, you can fly our payload onto a reused booster. So yes, that is some kind of things which SpaceX needs to prove with so many launches. So yeah, SLS is not going away right now. It will stay, but whenever Starship is there and it has proved and NASA has all faith in it, so SLS then could go away. Yes, Manat Singh, these are the same engine, the RS-25 engines developed by Aerojet Rocketdyne, although the company has now been taken over by Lockheed Martin. Is it? I don't remember right now, but yeah, it has been taken over by some company. And yeah, these are the RS-25 engines used in the space shuttle, but these are the modified versions of them. So yes. Exactly, with the New Shepard launch of the Blue Origin, the thing which I actually find really awesome of that launch is the drone shot which they get when the rocket actually flies up from the ground to the space. That drone shot is very epic. I actually find it very interesting. That's what makes me excited for the New Shepard launch, actually. So yeah. So guys, if you are new to this channel, let me just tell you that here on this channel we do this kind of things only. We discuss space, we discuss space flight, and you will find every rocket launch that happens in the space industry and every other space event also. And since we have some discussions on the space flight and all those things, so I do have some knowledge on that, so I do make some videos on also on those things. So yeah, this channel could prove to be a one-stop solution for everything. So yeah, you can consider subscribing, and you can always support me on Patreon. It really helps, and super chat is enabled for one-time funding. Right now it's 3 a.m. here and I'm still up, and I don't know when it will be. Test expected within an hour. Okay. Today I think again I need to be awake whole night. Yesterday also I was awake all night preparing for making the Kerbal simulation for the Electron rocket launch, but it didn't happen. Okay, no worries, but literally I was awake for whole night for making that Kerbal simulations, and the actual rocket launch was to happen at around 1 p.m. here in my country, but then also the time which it took was so much that I had to be awake. I literally had only 1 hour or 1 hour sleep, and yes, that's why if you just see the stream which I did, you could find that I was a bit low on my voice and my energy because I haven't slept yet, and today also I think I won't be able to sleep. So yeah. So yes, that's what it won't be happening if there wasn't a support from you guys. So yes, that's what the Patreons are there. Louis Smith always has been a constant Patreon for this channel. I really thank you for thank her for that. And yes, there is one more Patreon which joined, Marina Mann, yesterday. So yes, thank you so much for that. Now we can have a look at the the static fire which we have to see. But that they have updated their countdown test expected within an hour. I should be changing this also, so maybe what I can do is, now they are aiming for this much of time, maybe, I don't know, but since they are now saying this thing, so we can update the timer also. Yes, Manat Singh, only T-1 month from now. Yeah, around, yes, you are very right. And but not much time left, only T-20 days till it arrives in an orbit of the Mars. So there are 3 missions, 3 countries going to the Mars this time: the United Arab Emirates with their Hope Mars mission, the NASA with their Perseverance rover, and the China with their Tianwen-1 mission. So yeah, Mars will be pretty busy this year. China will be attempting to land in May, although they will be like injecting, obviously the injection will occur in somewhere in February only, but actual landing of their lander and the rover will occur in May. So yeah. Okay, so talking about this Artemis mission, this Artemis mission was planned for so much of time, but they weren't getting the funding, proper funding for that. And the thing is, they already have the hardware and every knowledge they want to have. Only problem is they don't have the faith on it right now, because obviously they need to test. First of all, the Artemis 1 mission will be all testing whether the things which they have learned from the Apollo era is still now valid or not. Obviously that will be valid, but with the upgraded technology, will they be able to actually do this thing? So Artemis 1 mission will verify the everything, the rocket, the upper stage and the Orion module and whatnot. So yeah, the recovery method also. So that will be a flyby of the moon. And yes, then after that Artemis 2 is also supposed to do that or not. Just a sec, I messed up the timeline over. Yes, they have a second stage. Actually the second stage depends on the configuration. That's what it is. Actually the second stage is a stretched version of the Delta IV Heavy. So Delta 4 or Delta 4 Heavy, the second stage they had that is the stretched version of that in this SLS rocket. So that's what we know about it. So since they have now stacked the rockets, the SRBs of the rocket, so they now have a timer on it. Means since they have now stacked it, they initially did in 2020 they did the SRB testing also, but now they have stacked it. So they now have around 1 year from the stacking operation to actually make this Artemis 1 happen, because that's after that there will be some problem with the hardware of it that won't be able to support the mission. So that's why they now have a timeline and countdown timer, basically you can say. So they now literally have to launch in this year or maybe January next year. That's what they now have the timer. So this is happening, guys. This is happening. That's what I have to say. This is literally happening, and we will be seeing the humans again on the moon, and obviously the first women on the moon, which will be flying on the Artemis 2 or 3 mission. So yeah. See, the thing with the Artemis mission, did you know about this NASA's Lu challenge? Do you know about this thing? So actually NASA, if you don't know, NASA actually had this competition where people were asked to submit the toilet design for actually a space toilet design. That's what I have to say. The space toilet design for moons. Yeah, when they will be actually going to the moon and they will be staying there, or yeah, whatever. So they don't know how to manage that. In Apollo time also, they had to actually, they didn't have any proper sanitation facilities, and obviously they didn't have that, but they literally had to throw their wastage away on the moon only. So yes, that's the biological component, you can say, which is present on the moon currently. And although the Beresheet mission also had some biological components, such as the tardigrades it had, which crashed onto the moon in 2019. But yes, other than that, the Apollo era astronaut faces and are there. So yes, now they actually have to manage, because people and one of the main reason why women was not selected for those Apollo era mission was this only, sanitary facilities, because the women has another type of requirement for sanitations. So that to accommodate that, it would be very hard to do that, which they weren't able to figure out at that time. That's what I have heard. So that was one of the reason why women was not selected. But now they are obviously working on that stuff. So yeah. So that was a pretty interesting fact which we got to know. And what else was there to discuss? You know that the Apollo era astronauts actually played golf on the moon. Yes, they literally played golf on the moon, and people actually thought that one of the astronauts smuggled a hockey stick and golf. Not the hockey stick, the golf stick on the the capsule, but that was not the reason. They actually had to, they did a science experiment, you can say, playing golf on the moon, how the gravity will affect the golf ball and whatnot. So yeah. Yes, Marcus Carter, I am so excited for the Artemis mission, I can just tell you. This is the most exciting thing which is happening in this decade. Yeah, for sure in this decade we will be seeing humans on the moon. That's for sure, whether it will be 2024 or 2026. But
you are
yeah.
watching NASA's Green Run Hot Fire test here at Stennis Space Center. The teams are in a hold, but we are still well within our window for today's test. And we did just get an update. And so we've got our expert here, Alex, a core stage engineer. Alex, what did we just hear from the control room?
So our test conductor is kind of discussing a path forward, obviously, with our test. Right now, we're about the T-minus 10 minute mark. So we're in a holding pattern for that T-minus 10. They're going to go around, continue to monitor our fuel levels, our propellant, how much propellant we have. Not only in the core stage itself, but also we have on reserve. And then over the next 10 to 15 minutes, they'll kind of have a discussion about, our propellant reserves, the path forward, and whether we're going to go into that T-minus 10 minute countdown sequence.
Okay, so we heard about one hold earlier when we started taking our pauses and listening in. This sounds like we're in a different hold, is that right?
Right, so the T-minus 10 hold is really the last major milestone before we get into a lot of the major operations that we use to get into the actual hot fire. So, starting at the T-10 mark, every minute we have a lot of very important tasks that we'll be doing up until hot fire.
Okay, so let's walk through those. What else will we expect to hear once we hit T-10? And then what are some of the calls we can expect to listen in on and expect going forward?
Right, so once we start T-10 count, we'll have a lot of software that gets initiated to start the hot fire, right? And some of that's automated, some of it's not. We'll move into activation of some of our major propulsion components. We'll turn on our CAPUs at about the 4-minute mark, and those are used to kind of steer our engines with our hydraulic system. From there, we'll start certain purges inside the engine section, and then we'll move into internal power within the rocket, so it's fully powering itself, and then we'll start the engine sequence.
And a reminder, this is a live show. We are listening into the control room. It's very important that Alex doesn't just keep talking, giving us interesting answers the whole time, because he needs to listen in to be able to digest what we're hearing so he can tell us what's going on and we can get more of an update. So we're going to do that now. We're going to take another pause. We're going to sit back with you just like you are at home, and we're going to watch the test stand. We're going to have Alex listen into the control room so we can come back and find out when we can watch the SLS core stage hot fire test. We'll be right back.
Okay, well, we didn't hear anything from the mission control, right? I was talking, but obviously the thing was going on. But yeah, we didn't hear anything, so maybe that was some fault. Anyways, so Manat Singh says radiation has changed the color of American flag on the moon, so it is possible. Yes, it is possible. It is possible. It is truly possible. Do you know that there is one more mission which is being planned, and that is being planned by one of the private space startup, and their mission is to literally go on to the Apollo landing site, and they had the rover, right? They had one rover which they drove at that time, and right now it is on the moon. So their mission will be to go to the landing site, take the rover, take it back towards the Earth, and then analyze it. So yes, that's what they plan to do, working on them, and that would be pretty epic. And obviously, since that will also have so much tons of scientific data and scientific analysis on it, how the metals behave in radiations and on the surface of the moon and everything. So it will be quite worthy, pretty worthy I should say, to analyze the rover which they actually left on the moon 50 years ago, to see how the metal and how the material behave in space environment on the moon and in the radiation. So yeah. It's looking like we are obviously right now on a T-10 minutes holds, but since he said that this hold is actually be there for around 10 more minutes, 10 to 15 more minutes, so roughly that accounts to around T-minus 22 minutes. That's what I have on the countdown, and I hope that they launch on this timeline. So let's see what happens. Waiting for everything actually. So guys, if you have any other questions, you can ask me, or else listen in to the rocket breathe. And if I get to know about, remember any interesting fact, yes, obviously then I'll come in and talk with you guys. So yeah, now listen in with the engine as it breathes and getting ready for its ignition. As Manat Singh asked, why are they testing it against when the space shuttle had already? Yes, actually the thing is they are testing it again because they have modified the engines, and this test is not for the engines basically. This test is for the whole rocket, which they are doing it right now. The engines are most likely to survive this test. That's not the problem. The whole rocket, how it performs, how what will be its data that they will get from it, that's what they are actually looking in for this test. So yeah, obviously the engines also will be tested for this, but mostly and mainly they are aiming for the whole rocket performance, whole core stage performance. How does it perform? So yeah. As Labrat says, if it ain't broke, don't fix it. And I think it's their own only option right now. Yeah, I do also feel like that only because looking like that, I don't think so. It will like there will be any kind of rut which will happen with this core stage now, because actually the thing is the fuel tank has also been tested and to its yeah, the fuel tank was also tested to its limit, and it performed really well. So now everything just need to go in sync with each other and see how well does this core stage behave. Guys, if you are just joining in, we are right now waiting in for the right now we are in a 10-minute hold right now, and officials are working on ensuring everything is going perfectly fine, and whenever any update we will have, they will obviously be updating us, so don't worry about that. And yes, if you don't know what will happen, so this is a static fire test of the 4 RS-25 engines which is installed in the core stage of the SLS rocket, which will be fired up for a full 8-minute duration test, and the software which will be fed into the system of the core stage is actually that launch environment, or the launch hardware, or the launch flight trajectory that will be actually be there in this rocket. So yes, the rocket will feel like that it is actually launching, but obviously it is not, because of those clamps, and clamps will have a very hard time putting it into one place, because it will have to deal with around 2 million pounds of thrust, so for 8 minutes straight. So yeah, and if you want to support us, you can become a Patreon. Link is down in the description. It really helps us. Thank you so much who are already our Patreons. And yes, Labrat, I also want to give you a shout out, because I can remember that $100 super chat which you gave in December with the Starship, when the Starship SN8 was flying. So yeah, thank you so much for that. It also actually had a really good impact on this channel, and I'm upgrading and trying to upgrade my stuff and my knowledge and my streams so that you can enjoy them. So yeah, thank you so much for everything. So this white kind of a smoke which you are right now seeing is probably because, yes, that the thing is some smoke is coming out of the rocket also, but if you will see that they have one sprayer bed just beneath the rocket nozzle, and that sprayer bed has water in it, water being sprayed out of it. So I think this white smoke is of that, and that will intensify, that thing will intensify as this thing goes to its full thrust. So yeah, the water needs to be there to suppress the sounds which come out of the rocket when the 2 million pounds of thrust will be produced, to actually have everything in one place sitting and vibrations are not exceeding their parameters. So yeah, that's what. Now listen into the ambient sound, and whenever they have the update we will get it. So now probably they need to be releasing their T-10 code, but we haven't got any update yet, so I need to update the timer. Okay, I was right with the timer. It is taking a lot of time now. And enjoy the ambient sound now.
And if you've been with us since the top of the show, you've heard me say this a few times, but we are so happy you're still here with us. You are watching NASA's Green Run Hot Fire Test here at Stennis Space Center in Mississippi. The teams are still in a hold, and we are still within today's window for the test. We do have an update, so I'm excited again to have Alex Cagnola here with us. Alex, what's happening right now?
So right now our teams are still kind of doing some preps before we move into our T-minus 10-minute count. There's a lot of just individual preps you have to do on the stand, individual components, certain configurations we have to put everything in before we actually do perform that hot fire. They're going around, they're polling all of our program management and our chief engineers to see, are we good to go on, or we need to move on. We're also monitoring other things. We're monitoring how much propellant we have in the tanks, how much propellant we have on reserve on the barges to use for the hot fire. And then just as we work through those issues, we'll hear more information as we get closer.
So you said monitoring how much propellant we have on the tanks. Why is that important at this step?
Right, so this whole test
can last up to 8 minutes. What I understand is we can learn a lot in just the first few minutes. Is that right?
Right. A lot of the engineering data we're looking to get really comes in the first 250 seconds. So, whenever we do initiate hot fire, we're going to be gimbling our engines a little bit, right? So we'll be moving the engines in a certain pattern that'll kind of mirror what we might expect during launch. We'll be throttling down the engines for a while, and then we might throttle them back up. There's a lot of things that we're going to try out, and most of those things will be in the first 250 seconds. Obviously, we want to go for the full 8 minutes that we will see during launch, but I think that we'll get a lot of really useful data in those first few minutes.
So you said gimbling the engines, moving them a little bit. It's not like a NASCAR turn or anything like that. We'll be seeing the engines, right? Just small movements?
Yeah, it's very, very small movements, and you might not even notice. It's only a few degrees in each way, and you might see a couple of them move the same time, or you might not. But that few degrees can really change your trajectory of your rocket when you do launch it. So it's important to be able to test that here at Stennis while we're hot firing, and not just when the engines are just sitting there, right? It's a lot different when you have all that thrust coming out the bottom of the rocket than it is just testing it without it.
So I'd love for you to take a second with me and just take a look back. We can see a little bit of white steam, smoke coming out. Can you describe that for us?
Right, so what you're kind of seeing right now is the max deflectors, the water deflectors on the flame ramp, right? So we kind of talked about how much water they're pumping, 110,000 gallons every 20 minutes or so. So it's a lot, it's a lot of water coming out, and roughly 32,000 holes on that flame ramp that are all pumping water. So, obviously you're going to see a lot of mist before the hot fire, and they'll actually even increase the amount of water coming up when we do get closer as well.
And those are called flame buckets, am I right?
Yeah, that's right. It's a flame bucket. You might even see some flame coming out of there whenever we do light up all four engines. So it'd be very exciting. Obviously all the safety systems are in place to take care of that when we do hot fire.
Okay, and again, we are still in a hold. In some way, this is a planned hold. We've got different versions of holds throughout the test. And as we get more information, we're going to come back. We still have Alex here with us. I'm not going to let him leave. You're going to stay mic'd into your chair right here because we want your expertise on what's going on. And as soon as we have more information from the control room, we're going to come right back to you. For now, we are going to take a step back and look at the test stand just like you are at home, and we'll be back in a few minutes.
So yeah, that was the water sprayer I was talking about is located just beneath the engine. those hexagonal structure. Okay, so that is actually a water sprayer, water bed, you can say that, which will act as a sound suppression system.
we've got our most exciting update in a few minutes. We are now inside terminal count. And again, I'm not the expert here. We've got Alex Cagnola with us, who's going to explain what that means and how did we get to this point.
Right, so the test conductor just came on the audio and alerted us that we're about 9 minutes away, actually. So we'll be getting some pretty regular updates here. We'll be hearing some activation of some different components on the rocket before the hot fire. And obviously there's a lot of steps that we'll be hearing going into the actual hot fire with things like we talked about CAPU activation, move to internal power. If there's any kind of audio that might slow down the terminal count, they'll kind of come on the air and tell us that too. But right now we are in that final sequence that lasts, 8.5 to 8 minutes. So we're going to sit back and kind of listen for the updates from the test conductor.
And this wasn't one person's decision. This is a full group that has to make the decision that we are ready to keep going.
Right, every big decision.
Hold on 1 second. What I do want to remind everyone now is that you're actually able to hear the control room audio just like we are. So what we're going to try to do is when the test conductor starts talking, I'm going to rudely cut Alex off in the middle of what he's talking about and try to make sure that we can all listen in, give him enough time to understand that call. So we just missed one. Again, this is a live show, but I want to get back to how we got to this decision. And again, it's not just one person.
Right, that goes back to, we have a great team working all the engineering issues, and then obviously, they kind of come up with a story about what's going on, and they present that in the best way possible to our program management and to, those who are the big decision makers. And so every time we have a big milestone like this, we have to poll the whole board. Everyone brings up their concerns, or if they think, going forward, what they think, and then do a go, no go poll. And it sounds like everyone was a go. So we're moving forward in terminal count.
Okay, and again, you can hear some of that test conductor audio. I'm sure you couldn't hear that one because you were talking, giving us a great explanation. But now I do want to know, so within these 10 minutes, we're now about 7 minutes, I understand. What are we expecting to hear from the test conductor?
Right, you'll hear a test conductor say a few things like initiate purge start, and that purge will be a nitrogen gas purge inside the engine section. That's part of just the normal sequence of purging the whole area around the engines before you initiate hot fire. You'll hear move to internal power. That's a big one. We'll take all the boxes and all the batteries, everything on board. The core stage will be powering itself, almost like you would have during launch. And then you'll move into ALS start, which is our pre-ignition engine start, and that'll be right before, 30 seconds before T0, where we'll power up the engines.
Okay, so we're about
6 minutes on my mark.
We just heard about 6 minutes. Was that right?
That is 6 minutes away, so they're going to start really having a lot more calls on the audio. We're going to hear, we might even hear some things being turned on inside the core stage. So, obviously we'll start talking less as we hear more audio comes through.
Okay, sure. What will those things sound like?
So you'll hear TCC, more and more calls. They'll be talking to more in the control room with individuals. They'll be talking to people.
Go ahead, sir.
Looks like somebody opened a terminal TCS window.
Yeah, nobody else should have the TCS GUI. If you have it open, please close it at this time.
So right, they're just working through some small things between all the monitors. They're opening and closing certain things that need to be closed inside the Rocky. From the stand. They're going to completely secure the stand with everything that needs to be done before the hot fire. And really, it's just the final preps before we do initiate engine start.
Okay, again, you are all hearing what we're hearing. We're pausing whenever the test conductor is speaking or other people in the control center are speaking because we're trying to learn what's happening to the rocket.
On my mark.
It sounds like about 5 minutes away on their mark.
So guys, it is finally happening and we will be able to see this rocket coming to its full power, and finally for the very first time 4 RS-25 engines will be ignited simultaneously to produce around 2 million pounds of thrust. So do look out for that. And thank you so much F1AZ Gaming for that $2 super chat. He says love the ship, it looks amazing. Thank you so much, it really helps the channel. So my
4 minutes 46.
I copy that.
Okay, so there is a hold.
It's the Delta P sensors.
Okay. Copy that. We'll wait till we get to the hold at T-minus 440. We're in the hold time. We're in the go. And if you want to go ahead and use that pre-plan.
DLH, let's go to manual mode and try to dial in lead Delta P, please.
if this is the right time. Can you break down what we just heard?
So they're moving into some final sequencing. Obviously, you can see on the flame bucket, they've now initiated max water flow into that flame bucket, so you'll be seeing a lot more mist
Just a
coming from
reminder,
that
we
flame
do have 2 minutes 35 seconds for the hold, so
It looks like you need to come down.
So we are 2 minutes 35 seconds before the 1 minute and 40 hold, from what I understand. So obviously that 1 minute 40 hold will be the last little bit before we do start up the engine. So it's very exciting.
You're getting excited.
Yeah,
I can hear
absolutely.
everyone around us getting excited. This is great. And what we're going to make sure we do is we have to make sure we're all being
you're
safe
clear to,
here.
reset that whenever you get ready. We are at 1 minute and 30 seconds in the hold timer.
Okay, if you're in the band, go ahead and reset MPS 17, please.
So we're going to go ahead and take a step back. We're going to put our ear protection on. So we'll be moving into internal power. And again, putting our ear protection on, listening in from here on out, and observing this major milestone on America's return to the moon with Artemis.
Enable the sequencer.
Sequencer activated. Resume and count on my mark. 3, 2, 1, mark.
Wow.
Now we're counting down. The sequencer is counting.
I'm so excited. I don't know whether I should update the timer or not. If there is a need, I'll surely update the timer. But this is happening, guys. Wow. I'm so excited for it now. Can't wait. Yes, Caroline, that's what I am also feeling right
up
now.
on T-minus 4 minutes on my mark. Mark.
Okay, so T minus 4 minutes. Okay. Wow.
And T-minus 3 minutes on my mark. Mark.
Okay, that gave me the thing to adjust the timer. So now it is perfect. I should say that. Okay, guys, it's happening, and I'm really sorry that I was speaking in between them because I am really excited for this thing. 2 million pounds of thrust in front of you will be happening. So excited. I'll also now shut my mouth and just enjoy this pretty epic static fire. Wow. It's looking like it will be worth to be
T-minus 2 minutes on my mark.
Be awake all night.
Mark. Come on T-minus 130. Mark.
Countdown is now fully perfectly sync. Okay, guys. T-minus 1 minute and 20 seconds in counting. I can't keep myself now because I can feel chills going into my body right now.
Coming up on T-minus 1 minute on my mark. Mark.
T-minus 1 minute. It's happening. It never gets old. I should say that.
For all personnel, report that you're ready to go. PEA.
Go.
AEA. HEA.
Go.
REA. Go. NTC. We're go.
Water is coming into its full power. T-minus 30 seconds.
All right, we're in ALS.
T-minus 20, 19, 18. It's happening. Trophies are ignited. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1,
And we're in the cross count. Engine start. We're in the cross count.
Just see this thing.
Call for south, please continue monitor your system. And grass is in control.
You want to listen to the rumble?
All right, plus 25 seconds.
Guys, this is so epic. See this huge cloud of water vapor coming out of the rocket. Wow. And it will continue for T plus 8 minutes.
CDRA, we did get an MCF on engine 4. Copy that, but we're still running. Still got 4 good engines, right? Copy that.
Wow.
It passes through 60 plus 60 seconds. Get into our first gimbal profile.
BTG is SE.
Gotcha.
What?
BTC violation on rest.
And we got a shutdown. All personnel. Shutdown looks like let's all go to page 656. Page 656, please.
Well, does not look that it went all right here.
Yeah, all personnel, it's going to be post-hot fire or shutdown securing operations on page 656.
BTD, I need you to verify with the engine guy.
Yeah, sorry about that.
Shutdown standby.
Yeah, all personnel, that does take us to the last page there on page 632. AR1, if you would, on step 4.241, please verify core stage engine 1s and 4 have shut down for that step, and we have a safe engine shutdown.
We are in post-shutdown standby, engines 1 through 4.
This is not looking good, guys. Okay, was not supposed to happen, but this happened. Although I heard that there was the mission control said that there was some problem with one engine, it was exceeding the throttle limit. I think that's the reason why they actually had this whole thing shut down, maybe. It's not nominal, yes, it should have been 8 minutes long, but they have...
We just saw the core stage of SLS fire up. Of course, we also heard some test conductor come in, so we want to go straight to Alex. Alex, can you please describe to us, first of all, what we saw and then what we heard?
Yeah, absolutely. Obviously, we had a very successful initiation of the engines. The beginning of our thrust profile there when we were firing for the first minute or so, we obviously were getting some really good data coming through. But like we said earlier, this is a test. We have test commit criteria and we have certain boundaries that we have to keep all the operations under. So, we really are trying to make sure that everything's operating properly and safely. So, the test team was kind of seeing some data that they might not like. And so obviously, our engines were shut down ahead of the 8-minute scheduled time frame. But we do have a lot of good data to go look at. and hopefully, we can move on from here and maybe get, see what's going to go on further. So
I was looking at your face when that started lighting up, and that was incredible. We saw the cloud forming. We both saw rainbows just forming right overside. Just how did it feel in those first few seconds?
Yeah, it's amazing. It never really gets old, that feeling that you get, in your chest, or, seeing, just how powerful those rockets are when they're testing. So obviously, it was an awesome thing to see, and, I can't wait to get the core stage to Kennedy and get ready for launch.
And you told us, over 8 minutes we might have had tons and tons, terabytes worth of data, but we already have data just from right now. What are they going to do with that right away?
Right, and so just like all of our other green run tests, we have teams that are going to go and break down that data and kind of see what we're seeing in our profiles, right? And so, that all goes into the profile that we'll use for launch eventually at Kennedy. So, obviously there's a lot of things to look at the data. We kind of talked about, over the span of our green run testing, we have roughly 800 terabytes of data, and that's a lot of data. We're talking about it's hard to grasp how much data that is. So, we'll obviously take the time to dig through everything, and then obviously have a path forward from there.
And I know it happened really fast, but can you tell us what the people were talking about that we could hear from the test conductor in that audio?
Right, so after we did engine initiation, they're kind of going through and monitoring everything, right? So obviously once we are actually firing the engines, we have to look at, all of our engine readings when it comes to temperatures, how they're reacting, how they're moving, and all that stuff. We were just getting into our gimbal profiling test, which is, moving the engines around right before we terminated the hot fire. So we're obviously going to have a lot of good data to look at.
Great. Thank you, Alex. I'm so glad you're here. And so as the engineers gather data from today, we look ahead to the next steps. This core stage will be lifted out of the B-2 test stand and refurbished to patch up that orange foam insulation. Then the team will load it onto our Pegasus barge, about as long as a football field, to make a 6-day journey from the Gulf of Mexico to our Kennedy Space Center on Florida's Atlantic coast. There, it will be stacked in the iconic vehicle assembly building with other elements of the SLS rocket, including the twin solid rocket boosters, which our teams have already begun stacking on the mobile launcher. The core stage will join the boosters and then be stacked with the upper stage. And then the Orion spacecraft with the launch abort system on top. All of this work putting us on track to roll out to Launch Pad 39B for a liftoff later this year on Artemis 1. We are going to pause again and just talk about what we just experienced. The stage was rattling that we're on here. We saw everybody with their phones out who's able to be here today. Talk us through from right when the engine started. What did we just see?
Right, so you kind of, those last minute and a half, right, you're kind of hearing the test conductor talk about, move to internal power. All go for ALS startup, which is engine startup, right? And then at T-0, you heard the final count where they're kind of polling all the people who are really watching the critical components of the rocket, those critical readings we need right before we initiate engine start. So after, everyone kind of gave their go, we initiated engine start, obviously. And that ALS, you kind of saw the pre-burners going on that rocket. You kind of see some of the sparks flowing, right? And that's all part of the test. And then right before they start flowing, that fuel and that mixture, and then it ignites, and you see it at T-0. So that's kind of what we were seeing running up to the test. And then after that, you obviously saw the plume and then the rest of the test as well.
And we saw a few different angles. We were up really close to the engines. How were we able to see that?
Well, obviously we have, the cameras and all of our views on the stand are, obviously well-engineered cameras, very protective casings and all that. It's all important that we not only get the data, but all the video and the view of what exactly is going on.
Great. Well, thank you again. We may still come back to you, but I want to remind everyone, it's not just Artemis 1. We've got several firsts on the horizon. This year, the first of our commercial lunar payload services, or CLPS missions, begin with 2 companies delivering instruments to the lunar surface. The golf cart-sized Viper rover will search for water at the moon's south pole. A small CubeSat called Capstone will head to the moon, scouting the orbit to be used on later human missions. And Artemis 1 launches on an uncrewed flight to test both SLS and Orion on a journey beyond the moon and back to Earth. Later on, we'll be launching the Power and Propulsion Element, or PPE, and the Habitation and Logistics Outpost, or HALO, to lunar orbit to become the first pieces of our Lunar Gateway, which will provide the jumping-off point for lunar missions. Artemis 2 will be a 10-day crewed test flight where astronauts will set a new record for farthest distance traveled from Earth. And finally, Artemis 3 in 2024. The hardware for those next 2 Artemis missions is coming together right now at Michoud. The Boeing team is already demonstrating faster manufacturing times by implementing all the experiences and lessons from building the first core stage. In Utah, Northrop Grumman is already building the booster segments for the next several missions as well. We've also got the Orion spacecraft for Artemis 2 down at Kennedy undergoing assembly. And the spacecraft for Artemis 3 is also being manufactured right now at Michoud in our hometown of New Orleans. So that wraps it up for us here today after a major milestone on America's return of astronauts to the lunar surface, a successful test of the core stage of the Space Launch System rocket. Up next, we'll be replaying the test, and we will have a post-test briefing in about 2 hours on NASA television. We invite you to follow all of our progress online at nasa.gov/Artemis program, or join the conversation online with @NASA Artemis and @NASA_SLS. Thank you so much, Alex, for being with here and being our expert tonight. Thank you to the administrator, Jim Bridenstine, and astronaut Tracy Caldwell Dyson. And most of all, thank you for joining us. And go Artemis.
I'll keep my mouth shut. Just listening.
And we're in the cross count. Engine start. We're in the cross count. All for South, please continue to monitor your system. And Brass is in control. All right, first 25 seconds. DRA, we did get an NCF on engine 4. Copy that, but we're still running. Still got 4 good engines, right? Copy that. The gas is through 60 seconds. Get into our first gimbal profile.
DTG, SFC.
Go, sir.
Do see some TCP violations on the rest.
And we got a shutdown. Okay, all personnel. Shutdown looks like let's all go to page 656. Page 656, please.
Okay. Well. Simply wow. Simply wow. Whoa, that was uncalled for, but I literally wanted it to see for around 8 minutes. This thing will never get old. Okay, this is my favorite static fire till now, I should say that. Okay, and this thing, I'm speechless. We know that although we had a problem with the engine shutdown. I mean, they said something I didn't understand. Obviously, that was some uh, way they were speaking NCS in the fourth engine. That's what they said, if I'm not wrong. But yeah, they got some good amount of data with the 60 seconds firing, if I'm not wrong. And with that, they will be able to actually now see how the engine have performed and everything. But I really suspect that there will be another static fire, although this wasn't a successful one, because it didn't run for around 8 minutes, which it was supposed to do. But yeah, it did run for some time, and they got some good amount of data from it. They had like some checkpoints of it. If something goes wrong, we will shut down the engine at this point. So yeah, the 60-second was one of them. So that's why I think that that's where they shut down the engine. And I don't think so they will be having another round of static fire, because they nobody mentioned about that, right? Nobody said that they will be trying again. I think the data which they have got from just 1 minute firing is more than enough for them. Maybe that's what the thing is. Priyanshu Malik says, really appreciate you, Rocket Gyan, waking up till 4 a.m. in the morning and doing the live stream of a booster test for folks abroad shows how much you love space. Yes, exactly. Thank you so much, Priyanshu Malik, for acknowledging this fact. I really love science, space, and I can just talk about and create awareness about it for so much time. I don't care about my sleep. It's okay. I'll do that. But yeah, this thing was pretty mind-blowing, and I will just cherish this moment every time. This thing, I don't know why, but this static fire was one of my favorite one. Yes, this was one of my favorite one, and this was the best one I had ever witnessed till now. So yeah. Okay, so in the meantime, I have got some updates for you. Um, they have this thing. They had this problem. So okay, so what they were saying that well, MCF was not a call in the major component failure is detected by the SSME controller. That's what they say, and there was some problem with the component failure, and that triggered a shutdown. Okay. Okay. Hmm. So in the next in the means the in the replay, I think that they played everything was perfectly fine, but in actual, when the it was happening in the real time, people are saying that there was a call out for a major component failure which is detected by SSME controller. Wow. Okay. Hmm. Okay. So it seems like if they had a problem with the major component failure, then it seems like they will have to have one more static fire. Yeah. So I think we will be having one more static fire, just because was something. Although it is pretty hard to get the accent, American accent for me, and then that radio voice is really very hard. But yeah, we got it that there was some issue with the some system. Yes, Octagrabber, it looks like that it failed just before the gimbal phase. Maybe it was like that. Actually, if there was a, because they mentioned that there was a problem, I also was trying to hear that there was a problem with the engine 4. Let's just replay this clip and see what actually they said. Okay, that would be pretty great. Okay, here we have it. No. Yeah, here we have it. So let's just watch it again, once again, and see. Just a sec. What actually went wrong? Listening for the mission control.
And we're in the press count. Engine start. We're in the press count. Call for south, please continue to monitor your system. And grass is in control. All right, plus 25 seconds. DDRA, we did get an MCF on engine 4. Copy that, but we're still running. Still got 4 good engines, right? Copy that. It passes through 60 plus 60 seconds. And we're in the press count. Engine start. We're in the press count. Call for south, please continue to monitor your system. And grass is in control. All right, plus 25 seconds. DDRA, we did get an MCF on engine 4. Copy that, but we're still running. Still got 4 good engines, right? Copy that. It passes through 60 plus 60 seconds. Get into our first gimbal profile.
DTG is SE.
Gotcha.
Do see some PCC violations on the rest.
And we got a shutdown. All personnel. Shutdown looks like let's all go to page 656. Page 656, please.
Okay, so it seems like they had a problem with one of the engine, because what I was hearing, that the mission control guys said that there was some MSI, major system failure of one engine, but then I also was trying to notice the smoke or the exhaust which was coming out of the stand, whether it has reduced something or what. But and we also didn't get any that after that call out, we didn't get any view of inside the this bay where we could see what engines are running or what not. So was there a fault with one engine or not? But the other 3 were running. That's what he said. I think what I actually got to know from that was this only, that there was some problem with one engine and other 3 were running. I think so. I may be wrong, but yeah. So yes, but whatsoever, see, if they had a major system failure, then that simply means uh, hopefully one more static fires, and that means we can relive this moment which we actually got to live for around 1 minute for today. I mean, that was so awesome to see this rocket actually static fire and relight all its 4 engines and produce around 2 million pounds of thrust. Wow. Okay, do I have any other update? Let me just see. More test is needed, yes. Nothing as such is there, but okay, whatsoever, we will have the another static. Whenever we'll have another static fire, I'll be again with you discussing with it, and hopefully be more prepared this time with the timings and all, so that we can talk a brief about this rocket and everything which we want to know before we actually go into looking for this static fire. So yeah, it was pretty epic, and I'm sure that they will figure out what went wrong and correct it, and hopefully get it on the stand again and for the static fire or another static fire. So yes, seemed like, yes, Octagrabber, it seemed like that there was some problem with the gimbal, I suppose, but we never know what actually happened. I am also looking in for any update if I can get, but right now it is not right now happening. So yeah, they will need some time. No one official, no, no, yeah, no one has tweeted anything. So yes, so I think I should end the stream now, and I'll come again tomorrow for another launch. Is it tomorrow or day after tomorrow? Okay, tomorrow we have a Virgin Orbit launch. I was also planning, since the Virgin Orbit will not be live streaming that launch, I was planning to make a KSP simulation for it. Whenever if they get like they have this success and we get to know about any footage of it, पता नहीं, I am not sure what I'll do or not, but day after tomorrow we have a Starlink launch and I'll be there for you. So thank you so much everyone for joining in. Thank you Angel, thank you Lab Rat, really appreciate that. Thanks Octagrabber and thanks Louis Smith, and thanks to all the moderator for moderating the chat. Really appreciate it. And yeah, until then, this is Priyanshu Roila. You just saw Rocket Gyan. Stay safe, stay healthy, and bye bye.